It's my pleasure to welcome to the Katz School one of our most successful alumni. As you heard from Kathy a moment ago, Tadeu Carneiro received the university's Legacy Laureate Award this year, the award which is given annually to individuals who are our most distinguished and successful alumni. He is the CEO of CVMM, a Brazilian company that's the largest producer of the element niobium in the world. It's an element that's used primarily to strengthen steel in the automotive, oil and gas, and heavy construction sectors. Tadeu is a 2012 Legacy Laureate. He's a metallurgical engineer by training, and his deep interest in the science of metallic elements drew him into the field. He earned bachelor's and master's degrees in that subject and worked first on the research, engineering, and academic side of his industry. As his career progressed, he took on larger business roles, and as part of that, he enrolled in the Katz School's Flex MBA program and received his MBA degree in 1998. Although he is the CEO of a global enterprise, he has a ground-level perspective on its operation. He began as a research engineer for the Technological Research Institute of Sao Paulo in Brazil, and in that role he handled over 100 cases of material characterization and failure analysis involving practical industrial applications. After that, he served as an assistant professor of physical metallurgy at his alma mater, the University of Sao Paulo's Polytechnic School of Engineering. In 1989, he joined CVMM as a market development manager, and in this capacity, he oversaw the worldwide responsibility for all non-steel applications of niobium. Under his leadership, CVMM grew to supply niobium titanium alloys to approximately 1/3 of all MRI machines in the world. Next, the company captured market share in areas of linear particle accelerators and high temperature applications. From 2002 to 2005, he was president of CVMM's North American subsidiary here in Pittsburgh. He became the director of technology for the company, which made him responsible for the entirety of its market development program. In 2008, he was selected as CEO. Throughout his career, he has stayed true to his metallurgical roots by continuing to publish and present scientific papers on a variety of topics. In this regard, he's a remarkable chief executive officer. He's also a remarkable alumnus of the University of Pittsburgh and a champion and friend of the city of Pittsburgh. By its nature, the minerals industry is truly global and has experienced a variety of changes because of the demand across the world to address commodity shortages. In that regard, I can think of no one who is better prepared to present on international business subjects. And I ask all of you to please join me in welcoming one of the University of Pittsburgh's most distinguished alumni, Tadeu Carneiro.
Thank you very much for being here to listen to this presentation. It is sort of difficult for me to really and truly explain to you the privilege that is to be here and address this audience. I had 2 great years here at Mervis Hall, during which I had the chance to go through my master's in the Flex 7 and interface best teachers ever. So they are really, really a great program that I had the chance and the privilege to attend, and it really changed my career. It was I was at a point where I was finishing one very important task for the company, and I needed to decide how to go further with the career, and the program fit extremely well in helping me address that task. So it was luck, I guess, to have that opportunity. You have to help luck in life, and I think we all do, working hard and really pushing as much as we can. And you know the feeling, working here or studying here. I am sure, absolutely sure that you do that. But you have to have that element of luck, and I had the luck to join the company I did. I had the luck to have the opportunity to come to Pitt and study here in this school, and this helped my life a lot. So I am truly honored to receive this from Kathleen, from Larry, from the Center of Latin American Studies. I will cherish this as a huge treasure. I think I know how to appreciate this, Kathleen, and I can't be thankful enough to the university for granting me this honor. Yet another one. I am Panthers. What can I say? I am Pitt, and my oldest son attended the School of Engineering. I'm working on the second one to come here, and hopefully he will. And I consider myself a true Pittsburgher. I learned baseball during years where the Pirates were a great team. 1990, 91. We are suffering a bit these days, but it's part of the cycle. I learned in the first year that I was here that if I didn't understand football, I would be left out of every conversation. So I learned football, and the second season I couldn't wait for the season to start. And so I probably know how to name almost all the players today. We do not miss a game for nothing, and we are very happy. You see, being a Steelers fans, you get to go to the Super Bowl. I explained this to the other guys, who are not Steelers fans, and so what can I say, right? So we are black and yellow all the way. And Pittsburgh all the way. It's difficult for other people, even in America, to understand how Pittsburgh is a hidden jewel in the U.S. And it is. You don't find a community that has all that Pittsburgh has to offer, being the size of Pittsburgh. And it takes a little bit of analysis to understand what happens. But it's easy to figure out why, and it is what it is: a blue-collar heritage, infrastructure for 3 million with 1.5 million people, all the endowments that were left by those hot shots from the previous centuries who decided to leave a little bit of the money to the community. So now I came to Pittsburgh. I had Mazel as the conductor of the Pittsburgh Symphony, and my friend said, "How lucky one can be! You're going to have Mazel, and so you have the ballet, you have the opera, and it's really unique what Pittsburgh has to offer, and it conquered me very easily, very fast. So I am honored to be a Pittsburgher. So when people say, have a pierogi for me. I know exactly what it is, where to go, you know, how it tastes. And so I want you to accept me as one of yours, because that's how I feel. Every time I touch down, every time the plane lands in Pittsburgh, it's like coming home for me. So easy to be here, very honored. It's a privilege. And what I would like to do today is to discuss with you a little bit on the subject of sustainability. Right? And again, I was lucky to be part of a program that was it started as a long-term program, and that's the first thing you have to have when you talk about sustainability. You can't have this urgent greed that some of the kids have today, you know, and look only on next quarter's earnings. You know, you can't if you want to talk about sustainability. And we are in the business school. Next quarter earnings are very important, but I'll tell you what, we went to China for the first time in 1978. So President Nixon left from one door and we came in another door. It's probably the only AIG was before us there in China. 1978. First seminar we put together to talk about niobium technology was in February of 1979. And it took us 22 years. Let me repeat this. It took us 22 years to sell the first pound of anything there. Now, we wouldn't survive as a public company with the analysts calling every day asking what's going to be the next quarter earnings with your Chinese program. You know? And yet we did. Today, China is the largest consumer of niobium in the world. It's responsible for almost a third of our sales. You look at the instantaneous shot of our business today, and you see, gee, that's great. You know, it's a wonderful business. Yes, it is, and it's too good to be true. Well, it is true, and it is good, and but it didn't fall from the sky. There are 50 years of a program to come where we are today. I try to convince people that we are a near monopoly, not a monopoly. Nobody listened to me because we sell 85% of the world's needs for niobium. And they said, oh, if you sell 85%, you are a monopoly. I said, well, okay, well, there are still 15% being sold by competitors. So we are a near monopoly. So anyway, it becomes semantics. But when we started, the market was zero. And we grew this market in a long-term program that I want to talk about a little bit with you and show you how did we do that. So if I could, I would be an astronaut. That's why I like this type of pictures in my presentations. It's my big frustration that I didn't make it. So what can I say? But anyway, you don't need to be an astronaut to figure out what's going on with our Earth, planet Earth. Here's a world map. We are here. This is Brazil. It's a pretty large chunk of land. And Brazilians love to say that if you don't count Alaska, we are bigger than the U.S. That's, you know, you hear a lot from Brazilians is, if you don't count Alaska, everything is bigger, right, in the U.S. So you've got to count Alaska, obviously. But anyway, it's the fifth largest country, fifth largest population. And to understand Brazil, and I mean, I'm not going to elaborate a lot on this. You probably know much better than I do. But to understand Brazil, you need to go back a little bit into history and geography, right? So I would say, I would point out this line here, a line that goes like this, is the Tropic of Capricorn. It goes straight through São Paulo. And then you have another line here. It goes here, more or less. It misses Florida. It's called Tropic of Cancer. So Brazil is in the tropical zone. And that makes a lot of difference. You have good weather all the time. You don't have that urgent need to do things. It's as that Aesop fable retold by La Fontaine, the grasshopper and the ant. It doesn't work just about everywhere. It doesn't work in Brazil. The ant got tired of delivering the speech to the grasshopper. Oh, if you don't work during the summer, come winter, you're not going to have food. Well, guess what? It's still in the tropical zone. So that impacts a lot how fast the society can get organized. In here, where all the developed countries, as they are known, are, society had to organize itself. You can't live underneath the bridges. Come winter, you die, right? So simple as that. Just to make the story short. Not in the tropical zone. You have crops all year round, for example. That is a big plus. So in Brazil, when I went back in 2005, there was this business magazine. The cover was showing a huge line of crop and crop feeders, and in front you were taking the previous crop. I mean, it's probably the only country where you can have that happening, and that's a big plus for Brazilian economy. It's a country that is very rich in natural resources as well, and all of a sudden commodities became much more important than they used to be. So that's why Brazil now has an even bigger chance of getting things going in the right direction and becoming a more powerful country in the future. There is this world conspiracy in favor of Brazil. Everybody wants Brazil to succeed. It's the next World Cup and the next Olympics. These are great enablers for infrastructure implementation. And I think Brazil passed the point of no return. I think it's relatively stable. It's improving as time goes. It became investment grade. So I think it got the elements to move on in history. Still a lot to do, big challenges. And the biggest challenge, in my view, has a lot to do what we do here. It's education. You can't grow the economy if you don't have skilled people to do whatever needs to be done. So to think of Brazil growing at 5% per year today, it's sort of difficult on a sustained basis, since we are talking about sustainability. Because of that, who is going to make it? So this is a big challenge for Brazil. Infrastructure is another big challenge. We need to be able to invest more in infrastructure in order to enable things to happen. But nonetheless, Brazil is much better than it used to be, and it's getting there. And to sustain its growth, it needs to solve these big challenges. When I was born, more or less when I was born, that globe that you saw there in the beginning had 3 billion people living on it. And now, see, I'm not that old, I'm still relatively young. We got 7 billion. I mean, think about that. From the days of the pterodactylus until the year I was born, we had some 3 billion people on Earth. And then some years passed, then we got 7 billion. You know, and in another 20 years, they say we're going to get to 9. And then you will tell me, you said, oh, Tadeu, it was always this way. You know, you got 1 billion people living more or less well, and then the rest, you know, it's a custom. Not anymore. Because there is something else that happened, which is a revolution in communication. Now, the guy is in, I don't know, pick a place, in Tajikistan, in a gas field. He knows who is going to be dancing Balanchine's choreography in the Lincoln Center tomorrow. I mean, you can't hide stuff anymore. Everybody knows everything. And well, you know, the Chinese, they learned how to have 3 meals. They liked it. They want to continue to have 3 meals every day. So, you know, you can't go against that. At lots of people. Lots of people. So 60% will be living in cities. You need infrastructure. You need education, food, fuel, housing, transportation, power, water. You need all this. So this is not a threat. This obviously is opportunity, but there is one thing that has to come to solve this. And to make this really an opportunity. And it is efficiency. You have to be efficient. You cannot go spending resources the way we were accustomed to. Because, you know, you have much more people wanting to use that stuff. So this is where the thing hook with commodities being a good thing now, all of a sudden. So you have good natural resources in Brazil. Okay, you are not industrialized, well, but you know, food, you have food, good. That's what people need. So you can get yourself organized around commodities this day, right? So it's a big challenge to get all this to all these people living today. You see today what happens when society decides to throw government out. You don't need a name. You don't need a leader anymore. You go to Facebook. Next time you know, everybody's in the square, right? It happened more than once recently. So that's how it works. It works different today. There's a transformation going on, right? That will make things completely different from now on, and we need to be prepared for these differences. And the name of the game, to be part of the next way of life, is efficiency. You may get into fights on what's going to be the maximum amount of CO2 that we are going to allow in year 2020. But you have to have a maximum. It doesn't matter which number you pick, you have to pick a number. And then you have to work to get to that point. Otherwise, you kill everybody. If you don't get the infrastructure in place for all these people, they will invade the cities. I mean, it's pretty simple. There is no a philosophical discussion here. You've got 7 billion people who want to eat properly. As simple as that. So, you need a solution, and you need a sustainable solution. A solution that stays. So what is sustainability? You know, in our case, we have mining in our scheme of things. And some scholars in the past didn't accept that a business could be sustainable if it involved mining. So there was this understanding that if it's not renewable, it cannot be sustainable. And I would like to show you that that's not true. I want to prove a point that this is not true. So you can't have sustainability when you have a business involving mining as well. This is the map of a strategy that we picked to be our sustainable program, you know, and it is it involves creating more applications for the product, doing it right, socially and environmentally, always investing in more efficiency in the processes, all the processes, making sure you have enough of your product and to satisfy demand, teaming up with your customers and making them your partners, and ultimately getting to maintain the leadership position that you have. So back to the original story that I was telling you. We started this program decades ago based on a laboratory dream. You know, like some of you are kids in the school, in university. In the 60s, there was this group of kids in Sheffield, in UK, University of Sheffield. And in laboratory, they found that niobium could transform steel. You put grams of niobium in a ton of steel, and it changed completely the way the steel, it could change. Depending on what you did as you manufactured the steel, it would make the steel much stronger without becoming brittle. Because every time you try to make a metal stronger, it becomes brittle, more brittle. And they found a way of doing both things together with niobium, adding niobium. That's what niobium does. This is a microstructure of a steel. If you get a piece of steel and you polish and you go to the microscope, you see grains. There are lots of grains. If you put 500 grams of niobium per ton of steel, same magnification here. That's how the grain becomes. It refines the grain. This grain refining is the only mechanism that does this thing, increasing strength and toughness at the same time. Increases the strength and the steel doesn't get brittle. So that's the claim to fame to niobium. Kids in the university discovered that. And then, at the same time, we discovered a niobium mine in Brazil. The largest, the easiest to mine, the safest. Market, zero. There was no market. There was a laboratory dream, right? And very well located, here is São Paulo, 400 miles north, straight line, is Araxá, where this mine is located. So now, if you had a cross-section in this mine, now looking this way, this is what you see. So this darker side here is the weathered zone of the ore. And we have, by the standards we use to define what is niobium ore, we have 829 million tons of ore. This is good for the next almost 200 years. So, got a marketing problem, right? So it's the largest inventory of anything on Earth. And so you have to create a market. But then, once you finish this 200 years from now, you get to the fresh rock. And we put together 3 holes, 800 meters deep on this thing. And we never found the end. So there is another billion tons of ore that is a little bit less in niobium than the weathered ore, still to go after you deplete this thing for 200 years. And it's funny enough, lots of people think that niobium is strategic metal. And with all this bunch of metal that we have there in the ground, some time ago, not long ago, WikiLeaks got an email from Secretary of State Hillary Clinton, and there were some, I don't know, 2,000 or 3,000 items of interest for the American economy or so listed, and this mine was listed. And then all of a sudden everybody got excited, right? Well, what happened is there are lots of other niobium mines in the world that we know of, and they are not used because there is enough niobium forever here, and we built this sustainable business that make the other mines not usable for now, right? But okay, what is strategic? To define what is strategic, people usually ask 3 questions. He said, is this important? Yes, it is. It's important. Can you replace without a penalty? No, you pay a penalty. You can't do the same replacing with something else. Do we have it? No, then it's strategic. Right? But with the new ways, and if you dig deeper into the concept and into the economics of niobium and the supply of niobium and the potential of our mines, I mean, there is no threat here, right? And everybody knows this. You can find niobium in every steel-making company in their raw material yard. You go there, you find a bunch of our drums or big bags with lots of niobium there. So it's not in the mine; it's already in the shop. So in any case, lots of niobium galore here. It's a marketing problem. We need to find a place for all this. Now go back 50 years ago, when this was discovered and when we had a laboratory dream. And the challenge was the following. A bunch of Brazilian engineers with their briefcases going to the Northern Hemisphere, coming here to talk to J&L or US Steel or Bethlehem Steel or ThyssenKrupp in Germany or Nippon Steel in Japan, saying, look, I came here to teach you how to manufacture a better steel. That was the challenge, right? It was not going to work like this, right? So we had to put together a plan that was a long-term plan. And we did. We started with several ways of creating this market. We put together in the beginning what we called a flying circus that had in its composition not only the Brazilian engineers, but those kids in the laboratory in Sheffield who invented these things, some other kids who started to use this in other countries and had the reputation. And then we started to fly this group all over the place, putting together conferences and seminars and discussions and everything. That's how it started in the beginning. Sponsoring degrees in all sorts of different universities. The program we had here at Pitt with the School of Engineering was one of the biggest ones in the beginning, trying to develop the fundamental understanding of the mechanisms of niobium. And so we replicated this in several universities around the world. Before moving forward with this, the opportunity for niobium intensified because of what we discussed before with that slide showing the 7 billion people that are living on Earth today. You need efficiency. You have to have infrastructure. Energy and natural resources are not going to get any cheaper, and the environmental awareness is not going to go away. So you have to be more efficient. And niobium does that, helps to do that. When you put niobium in the steel, and the steel becomes stronger without getting brittle, you can use less steel. You can do more with less. Cars can be lighter, so they will consume less energy. The structures can be lighter. You're going to be hauling less concrete and less materials, and so on and so forth. And that's what you need. So the best replacement for steel is better steel. Niobium can help doing this. I mean, people ruled out steel too many times already. So steel is past, and I'm not sure you want to have your family in a cardboard car, you know, hit something, right? So, and aluminum is expensive as it is today. Can you imagine when you have to manufacture 80 to 90 million cars a year? What's going to happen to the price? And then it's a religious thing, because only God can create all the energy that is necessary to manufacture all the aluminum for 80 million cars a year. I mean, it's pretty simple. So steel is going to be it. But you got to be better steel. You got to be more efficient steel. Okay, so how did we do to spread the applications of niobium technology? There was zero market. We needed to create this market. So this is pretty much how we do this. We have discovery with partnership. This is at the university levels. And then we would disseminate the knowledge that we would gather. So it's an investment phase where we would have projects with institutions. At first, most of it would be with university. These days, almost all the projects we have are with customers trying to implement the technology at their site, knowing how much they can do and do it with them. We have probably, this number is sort of conservative. We probably have 300 PhDs and masters that we funded during this program, and are spread out in the industry. And they became ambassadors of the technology. So it was a very important tool. And today we invest in understanding the capabilities of all the steel manufacturers in the world and trying to explain to them how they can use their capability in order to do things more efficiently. Look, you have something like 1.5 trillion tons capacity to manufacture steel in the world. Half is in China. And 80% of this was installed in the past 10 years. It's the most modern steel industry in the world. If they can't do it, nobody can. So not saying that we cannot beat them, but it's the picture that steel manufacturing in China is something that doesn't have quality. It's past. It's all German or American equipment that doesn't drop. You don't see a drop of oil out of place when you see, for most of the capacity they have. So they can do whatever in steel. They can implement more efficient technology. It's taking longer. They are the ones consuming the most niobium today in the world as a country. They passed the U.S. in 2005, 2004. As an individual country, the U.S. was the number one. And now they passed. And that's how we did. There are several tools that we used over the years. Partnership with customers, technical visits, inviting customers to see how we do things in our sites, seminars, meetings, all sorts of tools. This is the one event that I mentioned to you, the first one in China in 1979. And this is when we celebrated 30 years in 2009. The guy in the podium is the same guy. It's one of the British kids who invented the stuff. You know, it's John Malcolm Gray. But big fan of Pittsburgh as well. He used to come. He came from UK to work at JNL. And he is with us in our program since the beginning. More tools to implement the niobium technology. We sponsor a prize through the Institute of Materials in UK for the best paper published the previous 2 years in niobium technology. So there is an international panel who picks the best paper. Just another tool. So that's lots of investment. I mean, over the years, we invested 4% of the revenues in this program to enlarge the market. Today, we have something like 1% of our revenues. We are today approximately $2 billion company, and it is most of it helping customers with their budget in developing new products. Over these decades, we created the legitimacy to sit down across the table with these guys and discuss things with them as a raw material supplier in their view. So you don't see too many raw material suppliers participating in programs with an ArcelorMittal or with a Salzgitter or with a Nippon Steel. We do. This is one practical example of such a program. So these are the prime ministers of different countries in Central Asia, and here is the Chinese, when they opened the valve to get the gas flowing in the new pipeline crossing the whole of China. And this was 14 December 2009. 7 days and 8 hours after that, the gas arrived in Xinjiang. So this is the flare, right? And it's been flowing ever since. This is the second line crossing China. They will build the third one now. What is the relevance of this story? Efficiency. They built the second line with a better niobium technology. It's called X80. This is the specification for the steel. it has more niobium and less carbon on it. And with that, they can use only a little bit more steel per kilometer, and they can put more than twice the amount of gas in the pipeline. Now think about it. This is it. Gas is here, Central Asia. It can go up, go to Europe, or in this case, they decided that it would go to China. So, and then it has to cross the whole of China. That's where Zhangjiang took 7 days for the gas to arrive here. And then you have much more people here, no gas. Lots of gas here, no people, right? So, and that's how it works with transportation of gas. It's not a straw that you put there and suck very gently. You gotta put a huge pressure on this thing because you want the gas to go fast, a lot of gas, right? So it has to be something that holds a huge pressure. A pipeline is a pressure vessel with both ends open. That's what it is. So you need to be very strong steel and very tough steel. Because if you have a flaw and the steel is brittle, the velocity that you will have decompressing that is smaller than the velocity with which the crack travels. So the crack goes faster than the gas goes out. So guess what happened? The crack keeps going. You know, for thousands of, it does go for kilometers and kilometers, and then it has something very dangerous inside. It's a flammable gas that will catch fire. It will be a total disaster. So in order to change the specification and go from here to here, allowing twice the gas with a higher pressure, there's lots of thinking and lots of proofing to do. Otherwise, you're not going to do that, because when you use a less efficient car in terms of safety, and you crash the car, and everybody dies because you didn't have the right car, the right structure, fewer people know than when you have a crack in a pipeline like this. The whole globe will know immediately. So you can't, that's what made them move fast in changing the specification. Our program helped them do that. So all the specifications, because of old metallurgy, would limit the amount of niobium in the steel. Our developments show that you could put more steel with the modern steel technology. And the Chinese adopted very fast. So the third line is being built, very similar to that, and this is a very successful one. It's 6.5 billion yuan in savings for the capex, almost $1 billion yuan savings per year in the operating expenses for the Chinese. Efficiency. Simpler example. This is a tilting truck. If you use a stronger steel, again, you can't carry tons and tons in a cardboard structure. You got to be steel, right? So instead of having more steel and having more dead weight, if you put a stronger steel, you can increase the payload. So in this case, this is a real-life truck. You can have one extra trip for every 22 just because you put a better steel on it. And you are adding grams of niobium in a ton of steel. It's very little cost for them with a huge value added in the final product. And then the equation goes much beyond just the price of the ferroalloy, of the niobium. You have all these things that are part of the transformation in the business. You you transport less material when you manufacture this, you reduce the amount of residues, you improve ergonomics for the workers doing this stuff, you reduce welding consumables. I mean, the equation in terms of value added is much more complex than one can think, in a very simple example. And you have examples like this, I mean, in everywhere you look where steel is used. This is what our program does. Okay, now, good enough, but see, you've got to do it right. It's a beautiful story, but if you don't do it right, then it's not sustainable, right? Your workers need to be proud of working in your company. You need to create a culture of productivity, safety, and you do that when they put their head in what they are doing. And in order to do that, they have to have the basic concerns solved. So our social program is very comprehensive in the company. And it is not charity. It is good business. It's good management. And some of the elements I'm going to show here to you. I mean, our lowest salary is much higher than the minimum wage in Brazil. So it's 4 times higher. So the lowest salary in the company. Our objective is to have 100% of the housing needs covered for our workers. That means nobody spends any money with mortgage or a rent. Everyone has its own place. Kids for the workers have their education solved in terms of cost from the day they were born to the university, including the university. And then you have the other things, health care, retirement plans. This is not charity. It's good management. The worker, then you have a worker that wants to work for you. There is a line wanting to come in. You can invest a ton of money in training the workers because you retain the worker there. When you sell technology and you want to sit across the table to discuss technology with developed customers, you need to show that you do this home. So you ought to train a lot your labor force. So and all this return, right? It's pure good management. Our absenteeism is less than 0.5%, and turnover is a concept that we learn in the books. It's less than 1%. It's no magic. Environmentally, we're very proud of our environmental program. We were the first company to get certification for ISO 14000 in the world. It was not in the US, it was not in Canada, it was not in Germany, it was not in Australia, it was in Brazil, below the equator. The standard was issued in the end of '96, mid-'97, we were qualified, we were certified. At the beginning, we didn't advertise this. It was a threat to our customers, most of them. Said, how come these guys have? This is a pressure on us. So we were. And how do you get certified ISO 14000, which is the certification that has to do with the environment? It's because you already are ISO 14000. And from the beginning, we were. We could take care of the transportation of the ore from the mine to the plant with 6 trucks. And we installed in the late 70s a 2-mile-long conveyor belt to do that, to avoid all this fuel burning, as an example. We've been recycling 95% of the water in the plant. When you have a mining operation, the first thing you have to do is a washing machine. You have to wash dirt, which is called ore. So it's a lot. In our plant, for the current demand, we are washing 750 tons of ore every hour, 24 hours a day. Think about this. Say every hour, 750 tons, get lots of water in order to concentrate the niobium in the ore. 95% of this water we are recycling. In a couple of years, we're going to get to 97%. We've been always ahead of the legal regulations for environment. So, our investment in this tax, our tailings pond is recovered. It is all covered with polyurethane, and you don't want to wait for someone to pass a law that you have to cover a tailings pond to go there, dig everything, and then cover again. I mean, this is not how this thing is sustainable, right? So we have more vegetation in our site, 50% more, than when the mine was discovered in 1953. And it was not just any tree that you go there planting just to count trees. We had an inventory of all the species from the place. We produce that as part of our environmental program, and we replant native species, and we have 50% more than when we started. So these are examples of what we mean by environmental responsibility. Community. Tell you what, if the community is not proud of having you, you can get whatever license you want. You don't have a sustainable business. Simple as that. There are lots of examples that you can see today happening around the world. And we do a lot for our community. So listed here programs that we have with the city of Araxá. So we try to buy local. It represented 20% of our outlays. We created an industrial park there that started supporting our business and now became the source of equipment for lots of other businesses in Brazil. On top of the 72% of revenues that they get from taxes of our business, we have something like 5, 6, 7 million every year in projects that the community needs. So we have a program where we have a 1-800 number that we listen to what the community would like to have, and that's an inventory of wishes that we analyze and we use for the next 2-3 years to help the community. So Araxá is this is a picture of the first program that we had with the community in mid to late 70s. We built a vocational school equipped and donated to the community. So again, it's good for the business. So lots of kids being formed there every year, and it's a pool of skilled labor to support our company, our program. Doing it right. Efficient production process. See, when you handle a reserve, an ore reserve, you have a concession. Right? We have as an objective Our objective is to show that no one can recover better than we do what is in that ore that society is letting us use, right? Is letting us transform. They could do as good as, but not better. So we invest continuously in processes to be more efficient in the way we do things. There was no market. Then all of a sudden, we created a market, and now we supply 85% of the world's needs. Right? The last thing that can happen is someone needs a pound of this and can't get it. Right? So we will never let this happen. So we invest continuously in manufacturing capacity, and we invest continuously in visibility further down the road to have the material and supply the market as the demand increases. Right? Very important for the sustainability of the program. We continue with the programs with our customers to help them implement more efficient technologies and use more niobium, and this way we maintain our market leadership. See, this is the mining site. Conveyor belt takes the ore to the manufacturing facilities, and the manufacturing facilities have a concentration where you go from 2% niobium in the ore to 60%. Then you have to refine in order to get rid of some impurities. Then you have to reduce this and manufacture the ferroniobium that is used in the steel making. Or you manufacture the oxide, which is the feedstock for all the other niobium products used in the industry. There is no pound of ore leaving Araxá in the raw form. All the investment in technology and all the jobs are created there. It's not digging, shoveling into a bag and shipping ore. So it's a program that over the years evolved to supply finished products in the supply chain of niobium. That's the industrial site, a view of the industrial site. This is the current tailings pond, where we see you have 2% of niobium in the ore. So you concentrate this, 98 has to go somewhere else. So you dig 100 parts, 2 you use, 98 you have to put somewhere else. So this somewhere else is the tailing pond. And it's used also as our water tank. So as we wash this ore, we take the 2%, the water carries the other 98, it settles down here, and we pump back the water. So this is the previous tailing ponds. So as you increase the hole in the mine, you fill valleys that you have to select, properly select, cover, properly cover so you don't contaminate the soil or anything, and then you flatten this area. The industrial plant can't be inside the mine for obvious reasons. Otherwise, you would have to dig underneath the plant. Right? So then that's why you need a conveyor belt to take the ore, and it's a 2 mile long. Right? So more pictures of the industrial facility. Those are pictures of the concentration plant. The first refining plant, the second refining plant. Then here you see the reduction into a ferroniobium. This is the product that makes this business what it is. It's a ferroalloy used in the steel industry. 66% in weight is niobium, 34 is iron. And whoever makes steel gets 300-400 grams of this per ton of steel. And the rest is what I told you that happens. Now, traceability of quality is very important. If you paint an atom in the mine and follows it, it will leave the plant 38 hours later. 15 hours of this 38 has to do with quality control. So that's a big part in convincing whoever uses this that they can use reliably. That's also sustainability for the business. Examples where niobium is used. So this is the pipeline that I mentioned to you. It would look like this in some places. This is a bridge. We picked this one. It's a very nice. It looks like it's floating in the sky. It's southern France. Well, a couple things about this bridge. If it was not for this technology of higher strength steel, you wouldn't be able to put a bridge like this the way Sir Norman Foster, the British architect, wanted or conceived. It wouldn't stand. You have to be lean. The second thing is, if you use the normal technology to build a bridge, you would spend 60% more material. You want to talk about environmental issues? Using 60% less material to build the same bridge? Cars. Story I told you. It's lighter, safer because it's stronger, it consumes less fuel, it emits less. So it's needed. Energy generation. See, this is a man that is taller than me here. Just so you understand how big this thing is. Importance here is the following. This engines, these turbines for used in combined cycles when you burn coal in thermal facilities to generate energy. If you can operate this with 10 degrees Fahrenheit higher, you have 1% more efficiency in generating the energy. This is huge, huge. The combined cycle has 56, 57% efficiency in generating the energy only. So it is increasing 1-2% in this things means probably everything that the alternative energy will bring in the next 10 years or so. So efficiency, again, name of the game. To use higher temperatures, you need better materials, you need super alloys that, by the way, contain niobium in the composition. So that's also helping there. So, in our view, it is possible to have a sustainable business when you have mining in your scheme of things. It works like you are borrowing the atom from nature to use and make the world a better world. If you leave that atom there in the mine, it's going to do nothing. If you take the atom and put it in the steel that goes in the car, or in that turbine, or in the pipe, and you do it properly, you help the world be in a better world. So that's what we believe. That's what we try to do, and that's what we think sustainability is. So thank you very much for your attention.